Hello friends, I welcome you all to my channel. In this video, I will solve the problems of the DPP Sheet 2, which are problems on limits of the indeterminate form infinity minus infinity that I discussed in the previous video. So let's get started. Okay, so let's solve the problem. Uh, one thing I would like to say, I'm sorry that for the problem number 9, there is a mistake. The second term will be root x. So the first term is root over, inside we have x plus, and then again root over x plus root x, and the second term minus, after minus, it will be root x. I'm sorry for that. So let's start solving the problem. Problem number 1. So essentially all these problems are of the form infinity minus infinity, but still I will show how that for the given value of tending value of x, how the form is becoming infinity minus infinity for the sake of understanding. So this is x tends to 1, x by x minus 1 minus 1 by log x. So when x tends to 1 implies x minus 1 tends to 0. This implies x by x minus 1 tends to 1 by 0 tends to infinity. And log x tends to log 1 tends to 0. This implies 1 by log x tends to 1 by 0 tends to infinity. So therefore the form is infinity minus infinity. So as usual, we would like to simplify the given expression to transform it to the form 0 by 0. So if you do LCM, we get x log x minus x plus 1 divided by so this is of the form 0 by 0, and we can now apply L'Hopital's rule. And we get x by x plus log x minus 1 divided by x minus 1 by x plus log x. If we simplify this, we get 1 gets cancels out. We get log x. mm, let me see. I did it right or not. X by x plus log x minus 1. Okay. 1 gets cancels out. Log x by over here we get x minus 1 plus x log x, and the x in the denominator goes to the numerator. We get this. This is again of the form 0 by 0. So we can apply L'Hopital's rule again. and we get uh, x by x plus log x 1 plus x by x log x. This becomes this becomes we can now directly put the value of x as 1, and we get a finite value which is 1 plus 0 divided by 1 plus 1 plus 0. This is half. Half is the answer. Let's move to the next question. The next question says limit x tends to 0 cosec x minus 1 by x. So clearly we see that when x tends to 0 implies 1 by x tends to 1 by 0 implies this tends to infinity, and cosec x tends to 1 by sine 0 tends to 1 by 0 tends to infinity. So therefore we have the infinity minus infinity form. So as usual we would like to simplify this and transform into 0 by 0 form, and we get x 1 by x. This is x minus sin x x into sin x. So this is of the form 0 0, and we can apply L'Hopital's rule, but if in the denominator we have x sin x, so if we apply L'Hopital's rule we will get extra terms, and so it will be more time consuming. So let's do this. I want to get rid of the sin x from the denominator. So what I will do is I will do this and adjust the x. So sin x by x at x tends to 0 will become 1, and we will get in the denominator x square. So now we get x minus sin x square. Now this is of the form 0 by 0 form, and now we apply L'Hopital's rule. And we get 1 minus cos x divided by 2x. So this is also again of the form 0 by 0, and we again apply L'Hopital rule, and we get cos x differentiate becomes minus sin x. So sin x by 2, and now we can directly substitute the value x equals to 0, and we get sin 0 by 2, which is 0. 0 is the answer. Let's move to the next question. It says limit x tends to pi by 2 x x tan x minus pi by 2 sec x. So uh, it's better to translate the variable in trigonometry. It's better to have the the limiting variable to be 0. So let's see if we can do that. Let's let x equals to pi by 2 plus h. This implies h tends to 0 as x tends to pi by 2. So the limit becomes h tending to 0 pi by 2 plus h pi by 2 minus pi by 2 sec pi by 2 plus h. Over here we can just check that it is of the form infinity minus infinity, because when x tends to pi by 2, this implies tan x tends to 1 by 0 tends to infinity. This implies x tan x infinity, and sec x tending to 1 by 0 tending to infinity. So we have this limit. Now applying the trigonometric formula for allied angles, we know that tan of pi by 2 plus h is cot of h, but will it be same sign or the negative sign? Pi by 2 plus h is in the second quadrant, and in the second quadrant tan of any angle in the second quadrant is negative. So we will have minus cot h. Okay. So h tends to 0. Uh, we have minus pi by 2 plus h cot h, and sec. So pi by 2 plus h is in the second quadrant. Sec will be negative, and sec will be negative, and sec of pi by 2 plus h will be its co-function, which is sec cosec. So it will be minus cosec h. So it will become plus pi by 2 cosec h. Let's see. Let's proceed further. This becomes okay. Let's convert cot h to cos by sine and cosec to 1 by sine. See, minus pi by 2 plus h cos h by sine sine h. If I bring pi by let's bring the sign out common and we are left with uh, minus pi by 2 plus h cos h plus pi by 2. This becomes h tends to 0 1 by sin h. We merge the pi by 2 cos h and this pi by 2 term by taking pi by 2 common, we get 1 minus cos h and we are left with h cos h. Okay. Uh, Now we use the formula 1 minus cos a, 1 minus cos 2a equals twice of sine square. 1 minus cos 2a equals uh, twice of sine square a. So we get here 2 sine square h by 2 minus h cos h. Okay. Now we bring this 1 by sin h inside. We get pi sine square h by 2 by sin h minus a. We get minus h by tan h. Mm, okay. Now I would like to have add h by 2 whole square below sine square h by 2 and also this h below the sin h so that I can apply the formula of x tends to 0 sin x by x uh, limiting value is 1. So I will rewrite this as h by 2 divided by h by 2 whole square. Over here I will write sin h by h and adjust the h. So what do we need to adjust? We need to adjust the this h by 2 whole square. So h by 2 whole square and over here we have h by tan h. This becomes limit it tends to 0 pi of sine h by 2 this whole square. Over here we have h square and below h and this 4. Let's put this 4 over here and we have this sine h by h and a square h. So we will have h over here and this. I hope I'm right. A square by 4 h. Okay. So now if we substitute the value of h and the standard results for sin x by x and tan x by x, we get pi by 4 1 square. Over here it will be 8 0 1 minus 1. So the answer is minus 1. Let's move to the next question. This was 3. Number 4 says limit x tends to 0 1 by twice x minus 1 by x into e to the power pi x minus 1. So clearly when x tends to 0 implies 1 by 2x tends to 1 by 0 tends to infinity, and e to the power pi x tends to e to the power 0 tends to 1, e to the power pi x minus 1 tends to 1 minus 1 to 0, and so 1 by x e to the power pi x minus 1 tends to infinity. So we have infinity minus infinity form. So now, as usual, let's simplify this expression by taking LCM so that we get the form 0 by 0. Okay. So what do we get? 2x e to the power pi x minus 1. So over here we will get e to the power pi x minus 1 minus minus 2. 2. This was, 1 second. I think there's a small mistake in the problem. Let me check. Give me a second, please. Yeah, it will be e to the power pi x plus 1, not minus 1. So over here it is plus 1. I'm sorry for that. This is plus 1. So plus 1 basically is 2, but anyway x is 0, so the form. So we get this and twice x twice x e to the power pi x plus 1. This becomes x tends to 0 e to the power pi x minus 1 twice 2x to the power. If we have the standard result e to the power e to the power x minus 1 by x when limit x tends to 0 is 1. So we can see e to the power pi x minus 1, but in the denominator we have x, so we need the pi. So let's create that. E to the power pi x minus 1 divided by, let's put pi x over here. We already have the x in the denominator, so we need to adjust the pi, and the 2 will be here, and the rest, the term to the power pi x plus 1. Hmm. Okay, so this becomes this becomes 1 pi by 2 uh, to the power pi x when x is 0. This becomes 1 plus 1. So the answer is pi by 4. Okay, so let's move to the next question. Number 5. It says limit x tends to infinity, and we have a rational term, irrational term, x square plus cx minus x. So for this kind of problem, we need to rationalize this term. So we multiply with the conjugate of this irrational term in both the with both the numerator and the denominator, and we get uh, so when x tends to infinity implies x square plus cx also tends to infinity. So therefore, uh, also root over x square plus cx will tends to infinity. Therefore, this is of the form infinity minus infinity. So we rationalize the term and we get x square plus cx minus x, x square plus cx plus x, x square plus cx plus x. If we simplify the term in the numerator, we get, it's in the form a minus b into a plus b, we get a square minus b square. So we get x square plus cx minus x square. And the denominator, in the denominator we get x square plus cx plus 1. X square cancels out and we are left with tends to infinity. Let's bring the x from the numerator, from the numerator to the denominator. We get uh, x square plus cx by x, and over here we get 1. Okay, x tends to infinity. So this is, now we further simplify it. We bring this x inside the square root, and so it will get inside with x as x square. So we will get x square by x square plus cx by x square, and we have here plus 1. This is limit x tends to infinity. Over here we get 1 plus c by x. hmm. Okay. So now if we substitute x as infinity, we will get x c by x as 0, because uh, x tends to infinity implies c by x tending to 0. So applying this result, we get we get root over 1 plus 0 plus 1. This is c by 2. C by 2 is the answer. Let's see the next. Let's see the next question. This was 5. Okay. Let's see question number 6. It says limit h tends to 0, 1 by h 8 plus h to the power 1 by 3 minus 1 by 2h. So clearly we see when h tends to 0, 1 by 2h tends to 1 by 0 tends to infinity, and also 1 by h tends to infinity. So this is of the form infinity minus infinity form. Now we need to simplify this term to translate this to a 0 by 0 form. Mm, we have a plus 3 to the power 1 by 3. Okay, we have h common. Let's take the h 1 by h common, and we get uh, over here we get half. Hmm. Mm, 2 is 8 to the power 1 by 3. Okay, so let's simplify this further. This is 2 minus plus h 1 by 3 to 8 plus h 1 by 3. Hmm. We have 1 by h, that is the problem, and in the numerator we have 2 minus 8 plus h to the power 1 by 3, that is the problem. In the in the denominator, twice of 2 into 8 plus h to the power 1 by 3 is not a problem. So we can write this as 8 to the power 1 by 3 minus 8 plus h 3. The idea is to somehow get rid of the term in the numerator, and it is it is it has the form a to the power 1 by 3 minus b to the power 1 by 3, uh, and we can see if we somehow get the cube of both the terms, that is a minus b. We know the formula a cube minus b cube equals a minus b into a square plus ab plus b square. Over here a is 8 and b is 8 plus h. So a minus b is h. a cube minus b cube will be h, and that will get cancelled with the outside 1 by h, and this thing, this this thing will, are all positive, are all additive terms, so it won't create any problem. So we would like to substitute a minus b with a cube minus b cube divided by a square plus ab. This implies a minus b equals to a cube minus b cube divided by a square plus ab. We would like to use this formula over here in the limit, where a in our case is 8 and b is a 8 plus h. So this becomes um, okay, a cube minus b cube. So a cube minus b cube becomes, in the numerator, a cube minus b cube becomes 8 minus this thing, and over here we already have this thing, and we need to add this term a square plus ab plus b square, which is um, a square. What is a square? A is, what is a? Um, a is 8. Mm, 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 2 minus mm, oh, divide, 2 minus this, so this is 8 to the power 1 by 3, this is right, minus this 3 minus b is cube, a cube minus b cube is this, fine, and then we will have okay, a square is what? A square is 2 by 3 plus ab. Hmm. AB is what? And b square is 2 by 3. So in the numerator we are getting h, 8 gets cancels out, we get left with h, and it will also cancel out with the h in the denominator. Uh, uh, so it becomes limit h tends to 0. Basically we are having this thing, a3 into 8 to the power 2 by 3 is 4, plus 2 this thing and so we can now directly put the value of h as 0 and it becomes 1 by 0. So 2 into 1 by 3, 2, 4 plus 2 into 2. Over here we get uh, 8 to the power 2 by 3, which is 4. So mm, 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 4, 4, 4, 12, and over here 4. So mm, this is 1 by 48, but the answer is minus 1 by 48. Where did I do? Where is the mistake? Minus the numerator. 8 minus 8. Oh, it will be minus h. Okay, so it will be minus h, and when minus h get cancels out with h, it becomes minus minus minus. Okay, minus 1 by 48 is the answer. Let's move to the next question. 7. It says limit extends to infinity 1 minus n square plus like this n terms. Quite obviously, all the all the terms will tend to uh, mm, each individual term is tending to minus infinity. Mm, no, each individual term is tending to 0. This looks a different kind of problem. Uh, okay. Uh, we have all the similar terms in the we have similar terms in the denominator. So if we take xn, it should be n. Sorry, this should be n. So limit tends to infinity. If I take 1 minus n square common, so this becomes 1 plus 2, this plus n. 1 plus 2 plus up to n is, we know the formula, n into n plus 1 by 2, and over here we have 1 minus n square. Okay, so this becomes minus 2 n minus 1 n plus 2. So 1 minus n square is 1 minus n into 1 plus n, and we have rearranged 1 minus n, taken the negative outside, and we got n minus 1. So from here, mm, n plus 1 cancels out, and we are left with infinity n by minus 2 n minus 1. If we bring the n from the numerator to the denominator, we get uh, minus 2. Mm, we bring, okay, so this will basically become like this. This is gets simplified further, uh, minus half 1 minus 1 by n. So when n tends to infinity, 1 by n will tend to 0. So this is the answer is minus half into 1 minus 0, which is minus half. Minus half is the answer. Okay, so let's move to the next question. Says limit x tends to 2, 1 by x minus 2 minus twice 2x minus 3 x cube minus 3x square plus 2x. Okay. So clearly we can see when x tends to 2, 1 by x minus 2 is tending to 1 by 0 is tending to infinity. Similarly, if we substitute x as 2 in the denominator of the second term, it will become 0. So x minus 2 is also a factor of the this x cube term. So this becomes, if we factorize the denominator of the second term, we get x minus 2 x plus x minus 1. Okay, so we simplify it further and we get x minus 1 minus this further becomes uh, x minus this becomes mm, x minus 1 minus minus 3x plus mm, plus 3x x minus 2 should get cancelled out. Am I doing anything wrong? mm, x cube. Oh, sorry. There will be an x over here. First, we have to take x common out from this term, and then we are left with x cube x square minus 3x plus 2. If we factorize that, we get x minus 2 into x minus 1. So now uh, we get let's rewrite this. This becomes let me check if I did it right. X minus 2 x minus 1 x to x minus 1 minus, okay, so we have x square minus x minus 4x minus 5x plus 6 mm, plus 6 x square is 4x 5x plus 6. If we further factorize the numerator, it will be x minus 3 to x minus 2. So x minus 2 x minus 2 cancels out, and now we can directly put the value of x as 2 in the expression, and we get and we get 2 minus 3 2 2 minus 1. This is this is minus half. Minus half is the answer. Let's move to the next question. Okay. So actually there is a mistake in the DPP sheet. It will be x tends to infinity root over x plus this will be minus root over x. So clearly this is of the form infinity minus infinity, and we need to rationalize this by multiplying with the conjugate term with both denominator and the numerator, and we get x plus over. So this further gets simplified to we apply the formula a minus b into a plus b, which becomes a square minus b square in the numerator, and it becomes x plus okay, this becomes x gets cancels out, we are left with Hmm, hmm. uh, X plus. So since x is the tending to infinity, we are having the form infinity by infinity, and the strategy is to uh, divide both the numerator and the denominator with the highest power of x, so that lot of terms will become 0 as uh, x will have in the denominator, and since x tending to infinity will become 0. So mm, mm, we can mm, x mm, and from the numerator from the numerator, if we take x common, we will have in the inside the root 1 plus 1 by root x. Okay. Mm, mm, stupid. Is everything is right or wrong? X plus 2 is minus. Okay. Uh, X X. Mm, okay. Let's take X common. If I take X common from the numerator, I get uh, root X into 1 plus 1 by root X. So when I take X common, it will come outside the square root as root of X. And in the denominator, the first term, if I take x, if I take x common, mm, and so it will come out as root x, and we will have uh, 1 plus x. Mm, this will be x plus root x by x, and over here we have root x. mm, X common root x 1 plus okay. So from the denominator and the numerator, the root x will get cancelled out, and we are left with 1 plus 1 by root x, and this thing over here 1 plus, when x gets inside the square root, it will become x square. So uh, it will become x square. So x by x square is 1 by x, and root x by x square. Mm. root x by x square is 2 minus half 3 by 4. Anyway, so it will be like x square. So x root x plus 1. Now all the 1 by root x will become 0 because x is tending to infinity, and also the 1 by x and the 1 by root over x, all these terms will become 0. So the final limit becomes 1 plus 0 divided by root over 0 plus 1, which is which is half. Okay, so the half is the answer. Let's move to the next question. It was 9. 10. It says at n tending to infinity, n plus 1 2 by 3 minus n minus 1 2 by 3. So clearly n plus 1 is tend to infinity, and also n minus 1 is tend to infinity. So it is of the form infinity minus infinity. Again, so we see n plus 1 power, we see 1 by 3. Basically, we have to get rid of this minus. It's kind of we know a cube minus b cube equals a minus b. So this a minus b is creating the problem. If we see a cube minus b cube, it will be n plus 1 whole square minus n minus 1 whole square. From there, n square will get cancelled out. Also, 1 will get cancelled out, and we will get 4n. So, applying this formula, we get limit x tends to infinity. So in the numerator it becomes a cube minus b cube. So n plus 1 square minus n minus 1 square. in the denominator we get a square plus ab plus b square, which is uh, 4 by 3 n plus 1 n minus 1 2 by 3 2 by 3 plus n minus 1 4 by 3. Okay, let's simplify it further, and we get in the numerator we get n square 1 cancels out, and we get 4n. mm, we get 4n. Okay. In the denominator, mm, 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 if we take n common, let's see, if we take n common, we will get mm, from h plus 1, if it take n common, it will come out as n to the power 4 by 3. N to the power 4 by 3, and this is 1 plus 1 by n 4 by 3. This is actually n square minus 1 whole to the power 2 by 3. Mm, this is this part is n square minus 1 whole to the power 2 by 3. So we would like to take n square common, which will come out as n to the power 4 by 3, and over here we have 1 1 minus 1 by 1 by n square. This is 2 by 3. Mm, and for the third term, we will also bring n common, and we are left with okay. So we have n to the power 4 by 3 common from the denominator. And all these 1 by n terms will become 0 because n is tending to infinity. So let's see, n tends to infinity, 4 by n divided by n to the power 4 by 3, and 1 plus 1 by n 4 by okay. Mm, hmm. This term will not when n is tending to infinity, this whole term will become 1 plus 1 plus 1 3, because all the 1 by n and the 1 by n square term will become 0. This is becoming 3, but uh, here we have n, and in the denominator we have n to the power 4 by n. So this is mm, n to the power 1 by 3, and over here we have got 3 already. 4 by n to the power 1 by 3. N is tending to infinity. So when n is tending to infinity, any positive power uh, uh, x tending to infinity implies x to the power n, where n is any rational number greater than 0, will also tend to infinity. So this becomes 4 by infinity, so 0. So 0 is the answer. Let's see the next question. Mm, 11. In the previous video, if you have seen it, I have solved a similar problem where the problem was x tends to 1, uh, n by 1 minus x to the power n minus m by 1 minus x to the power m, where n and m are natural numbers. For this, the result is always n minus m by 2. So when x tends to infinity, n by 1 minus x to the power n minus m by by 1 minus x to the power m, the formula is n minus m by 2. So we can directly use this formula and solve the problem number 11. So the answer will become, it is given that x tends to 100, 1 minus x to the power 100 minus 50. Over here n is 100 and m is 50. So, so the answer is 100 minus 50 by 2, which is 25. Please check my previous video where I have solved this limit, n by 1 minus x to the power n, this one. Then you will understand. So let's do problem number 12. Okay, so limit x tends to 0, 1 by x square minus sine square x. So again, x tending to 0 implies 1 by x square tending to 1 by 0 tending to infinity, and sine square x tending to 0, 0 implies 1 by sine square x tending to 1 by 0 tending to infinity. So therefore it has the infinity minus infinity form. Let's simplify the given limit and we get sine square x minus x square sine square x. So this is of the form 0 by 0. Now at this point of time we can apply L'Hopital's rule, but in the denominator we have x square sine square x. It will create a lot of terms, extra terms, when we will differentiate that. So I would like to get rid of the sine square x by transforming it this sine square x minus x square. I will bring x below like this and adjust the x square. Hmm. Hmm. Uh, uh, hmm, hmm. 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 So sin x by x whole square, and we are adjusting this. So we can directly use the formula limit of x sin x by x when x tends to 0 is 1, and we get sine square x minus x square by x to the power 4. We have applied the standard result sin x by x equals to 1 when x tends to 0. Now this is also of the form 0 by 0 and we can apply L'Hopital's rule. So we get 2 sin x cos x minus twice x 4x cube. Hmm. 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 Twice sin x cos x is sin 2x. Hmm. So this is again of the form 0 by 0 and we can apply L'Hopital's rule once again and we get sin 2x 2 cos x minus 2 12 x square. Hmm. Hmm. Now hmm, x cos 2x. We can write this as limit x tends to 0. We can take minus 2 common and 1 minus 2 cos x divided by 12x square. This becomes minus 2 by 12. Let's bring minus 12x square. So minus 1 by 6 outside and 1 minus cos 2x is 2 sine square x and we have in the denominator x square. We bring the 2 outside and we get minus 1 by 3 limit x tending to 0 sine x by x whole square. So this is minus 1 by 3. As we know, the limit x tends to 0 sine x by x is 1. So minus 1 by 3 is the answer. Let's move to the next question. This was 12. 13. Uh, mm, says limit x tending to infinity x cube by 3x square minus 4 minus x square by 3x plus 2. So x tending to infinity. So definitely it is of the form infinity by infinity, because in both the terms we have higher powers of x in the uh, numerator. So x tending to infinity uh, implies x cube by 3x square minus 4 will tend to coefficient of x cube is 1, and coefficient of the highest power of x in the numerator is 1, and the coefficient of the highest power of x in the denominator is 3. So this will tend to uh, x, and since x is tending to infinity, x is tending to infinity, so this will also tend to infinity. Similarly, we have x square 3x plus 2 will tend to 1 by 3 x tending to infinity. Therefore, we have infinity minus infinity form. Now, let's simplify this expression, and let's see what happens. The idea is to, whenever we have an infinity minus infinity form, we simplify the given expression. It will, and in most of the cases, it will get transformed into the 0 by 0 form, and from then onwards you can apply the standard results, or you can modify the expression and cancel out something, do rationalization, do factorization, and or apply L'Hopital's rule to get the final result. That is the basic strategy. So over here we have x cube 3x 3x plus 2 minus x square 3x square minus 4 3x. Hmm, 3x to the power 4 plus 2x cube minus 3x to the power 4 plus 4x square. Three x 3x to the power 4 gets cancelled out, and we are left with hmm, mm, one factor should cancel out. The 3x square minus 4 cancel out. Let me see if I did it right. Hmm. Huh. 3x plus 2. X cubed 3x plus 2 minus x square 3x square minus 4 3x square minus 4 plus 2 3 x to the power 4 plus 2x cubed minus 3x to the power 4 plus 4x square. Oh, sorry, this is x tending to infinity. Okay, So let's see what happens. Hmm. This become limit. So in this kind of problem, the basic strategy is to uh, mm, divide all the terms with the highest power of x. Since x is tending to infinity, so with the highest power of x in both the numerator and the denominator. So we are left with 2x cube plus 4 x square mm, and 3 x square minus 4 3x plus 2. So the highest power in the numerator is 3. Also the highest power in the denominator is 3. The coefficient of highest power of x in the numerator is 2, and the coefficient of the highest power of x in the denominator is 9. So the answer should be 2 by 9. Okay. So we take the we take out the highest power of x from both the numerator and the denominator, and we get this in the numerator. In the denominator, from the first term we take out x square common, and from the second term we take x common, so we get this. So x cube cancel out from both the numerator and the denominator, and we are left with hmm, okay. So the 4 by x will become 0 as x is tending to infinity. Also the 4 by x square will become 0, and also the 2 by x will become 0. So the answer is 2 plus 0, 3 minus 0, 3 plus 0 equals 2 by 9 is the answer. Let's see the next question, 13. So now 14. 14, it's a complicated expression. Let's see. Hmm. Hmm. X tends to 2, x cube minus 4x by x cube minus 8 to the power minus 1. Here we have x plus root over 2x by x minus 2, and we have this thing. Now, mm, mm, we need to simplify this. From the second term, we can see in the denominator we have uh, mm, mm, okay. So let's try to simplify this expression first. What this becomes? X plus root 2x. Uh, this is the form we can use a square minus b square. We can write it as uh, uh, we can write this as uh, root over x minus root over 2 and so this becomes um, x plus 2x minus 2 multiplied by root x plus 2, and below we have this thing. This gets simplified to uh, root over 2x cancels out. We are left with um, x minus 2. And also if we multiply both the factors in the denominator, we are getting x minus 2. So basically this is 1. Okay, 1. So this becomes uh, limit x tends to 2 x cube minus 4x by x cube minus 8 minus 1 minus 1. Okay. Mm, this is basically x cube minus 8 by x cube minus 4x minus 1. Mm, this is x cube minus 8 minus x cube plus 4x. X cube minus 4x. X cube cancels out. We get if I 4x minus 8. So x minus 2, and if we take x common, we get x square minus 4. Okay. We further simplify this, we get 4x minus 2 x minus 2 multiplied by x plus 2. So x minus 2 cancels out. Now we can substitute the value of x as 2, and we get 2 plus 2. This is half. So the answer is half. Let's see the next question. says limit x tends to infinity x minus x square log 1 plus 1 by x. So x tends to infinity. Definitely it is of the form x tending to infinity implies 1 by x tending to 1 by infinity tending to 0. This implies 1 plus 1 by x tending to 1 plus 0, 0 tending to 1. This implies log e 1 plus 1 by x tending to mm, 1 by x tending to infinity 1 by x 0 1. Also log of e 1 plus 1 by x is tending to 0 tending to 0, but we have x squared. So it is not actually of the form infinity minus infinity, because x square is tending to infinity and log of e 1 plus 1 by x tending to 0. So infinity multiplied by 0 is an indeterminate form. Mm, Also we see there is log 1 plus 1 by x. We know a formula, standard result, when x tends to 0, log of 1 plus x by x is 1. So how about changing the variable x? Let uh, 1 by x equals to t. This implies uh, so we are actually transforming the limiting variable to tending to 0, from infinity to 0. This implies t tends to 0 as x tends to infinity. So the limit becomes limit t tending to 0 1 1 by t 1 by t square log 1 plus t. Hmm. Uh, if we simplify it further, we get uh, t minus log of 1 plus t by t square, 1 by t square log of e 1 plus t. So this is the form now 0 by 0. The 0 by 0 form. From here we can apply L'Hopital's rule, and we get limit h tends to 0 1 minus 1 by 1 plus t divided by twice t. This becomes 1 plus t minus 1. So 1 plus t minus 1 t by twice t 1 plus t. T cancels out and we get 1 by twice of 1 by t. Sorry, this will be t. This will be t. So now if we directly now substitute the value of t as 0, we get the answer is half. Okay, so let's do the last question. It says limit x tends to pi by 2 sec x minus tan x. So, what is the form? X tending to pi by 2 implies sec x tending to 1 by cos pi by 2. This definitely tending to 1 by 0 tending to infinity. And tan x at pi by 2 tending to sine pi by 2 cos pi by 2 tending to 1 by 0 tending to infinity. Therefore, this is infinity minus infinity form, and we would like to simplify it and transform it into 0 by 0 form. This is 1 by cos x sin x by cos x. This becomes 1 minus sin x by 1 minus sin x by cos x. Uh, this is of the form 0 by 0 form. If we apply L'Hopital's rule, we get minus cos x by so we now apply L'Hopital rule and we get limit x tends to pi by 2 minus cos x minus sin x. This is cos pi by 2 by sin pi by 2 equals to 0 by 1 equals to 0. 0 is the answer. Okay, so we are done. Thanks for watching, and in the next video I will start discussing the indeterminate form of the I will start discussing the exponential indeterminate form like 0 to the power 0, 1 to the power infinity, and infinity to the power 0. And also I will try to provide a DPP. As usual, if you like this video, if you find this video useful, please support me by subscribing to my channel and like this video and share my channel and the videos with your friends. That will help me. And please do not forget to press the bell icon so that you will be notified by my future videos. And yeah, that's it. Until the next video, take care and bye.